Hey everyone. So today we're going to be talking about limits, specifically what are they and what kinds of limits are we going to be looking at in this class. So very specific. This is a little bit more of a conceptual video, so I would encourage you to take good notes and to look closely at the pictures and listen to what I'm saying. All right. So what is a limit? A limit asks a question. The question is, what is the output of the function doing? In other words, the y value of the graph, as the input, meaning the x, approaches a particular value. And the best way to explain what I mean by the word approaches is to describe what happens on the graph itself as a picture. And that's what we're going to be going over. We're going to see a lot of examples today, but really no formulas. I'm just looking at all of these questions based on the picture of the graph itself. So in this example, I'm asking the question, if x approaches 1 from the left, what is y approaching? So I'm imagining that I'm on this graph, and the x value on this graph is getting really close to 1. So watch my cursor here. It's getting close to 1 from the left, which means from the side that's where x is a little bit less than 1. And well, what is y approaching as x does that? The question is always about what y is doing. And in this case, y is getting close to 0. And it's getting close to 0 for a pretty simple reason in this case. The reason is that the value of the function when I plug in 1 is actually 0. So this is the easiest case of a limit, although because it's easiest, sometimes that means it's ironically the most confusing. But the answer to this question is y is approaching 0. All right. So there are different types of limits, or basically different ways that I can ask this question. And the first way is a one-sided limit. A one-sided limit asks the question that we asked in the last slide, as x approaches a particular value from either the left or the right, what does y approach? Okay, so part of the question will always be, what is x approaching? And is it approaching it from the left or from the right? So in this example, this is a piecewise function, right? The kind of function where I have two different rules, and depending on what x is, I use one of those two rules. And so these piecewise functions are the ones where we have to be a little bit careful with these one-sided limits. So for this function here, as x approaches 0 from the left, what does y approach? Well, I look on the graph, I watch, okay, if I'm to the left of 0, that means I'm on this blue line. And if I'm getting close to 0, then what is y getting close to? Y is getting really close to 1. And so what I say is that y approaches 1. Now we have notation for limits that is more compact than writing out this full sentence. And here is this notation here. So this is the notation for a limit of a function, in this case f of x. Let's suppose that this graph is f of x. As x approaches a value from one side. And I'm going to zoom in really carefully here so that you can see this if you're watching this on your phones. Okay, this is the notation right here. X is approaching 0 from the minus side. The minus here means that I'm approaching it from the left, which means that I'm approaching it from the side that's less than 0. And in that case, I get 1. Okay, I'm going to scroll back up. So here, in the second case, now I'm approaching 0 from the right. And in my notation, that's what this plus means. Super important that we be able to remember that the minus that appears here means from the left, and the plus here means from the right. If I approach 0 from the right, then I'm on this red line here, not the blue line. And what's this red line getting close to? As x gets close to 0, y is getting close to -2. So these are different. The left-hand limit, which is another word for this, is 1, and the right-hand limit is 2. Okay. Notice that in this question, in this case, I didn't actually plug 0 into this function at all. If I did plug 0 into this function, I would get the -2 because that's where the closed circle is. That's what the closed circle means, remember. But that is actually completely irrelevant to this particular question. And if that closed circle was up here at the 1 instead of the -2, that wouldn't actually change any of these two answers because I'm only interested in what y is approaching, not what it actually is. Okay, key point. So what can the answers to these limit questions be? In this case, the answer to this first one is 1, the answer to the second is -2. But so definitely the answers can be numbers. They can also be infinity or minus infinity, or it might be the case that the limit just does not exist at all. Okay, and we'll see examples of all of these in the next couple of slides. But just keep in mind that the answers can take any of these forms, but nothing else besides these. Okay. By the way, you might also in class hear me say undefined for a limit. That's just the same thing as does not exist. All right. So a two-sided limit is pretty simple if you understand a one-sided limit. A two-sided limit is asking if y is approaching the same thing when x approaches a particular value from the left or from the right. So it's asking, is the one-sided limit, is the left-hand limit equal to the right-hand limit? If so, then that value is what we call the two-sided limit. All right, so I've got two different examples here. In this first example, this is a function with a hole. We've seen this before, right? Functions have holes when they have values that I can't plug in, but that would cancel if I simplify the function. And I'm not actually really paying much attention to formulas in these examples at all, except in this case, just so you can see how this function might happen to have a hole at x equals -1. Okay, but regardless of that hole, the limit as x approaches -1 from the left is still y equals 2, because as I'm getting closer on the graph from the left side, y is getting closer to 2. If I approach from the right-hand side, also 2, right? It's just coming down from above instead of coming up from below. So what that means is the left-hand limit is equal to the right-hand limit, and therefore the two-sided limit is also equal to 2. Now, the way that I notate the two-sided limit, I'll zoom in, is pretty simple. It doesn't have the minus or the plus. It has a minus here, but that's because x is approaching -1. But notice that up on the top, I have this minus, which means left-hand limit, and this plus, which means right-hand limit. When I don't have anything at all, that means a two-sided limit. Okay, so in this second example on this slide, actually, it's the same example from the last slide. But remember this case, the left-hand limit is 1 and the right-hand limit is -2. Therefore, they're not the same, right? So the left-hand limit doesn't equal the right-hand limit. And therefore, the overall, or the two-sided limit of f of x does not exist. Because for that to exist, they would have to be approaching the same thing from both sides, and in this case, they're not. So the only thing we can say here is does not exist. Okay, last example. So in this last slide, I'm asking what happens not as x approaches a number, but as x approaches infinity or minus infinity. So those are also questions I can ask. And when I'm talking about this kind of limit, I call this the end behavior of the graph. So when I say something like find the end behavior, what you're being asked is find the limit as x approaches infinity and as x approaches minus infinity. Okay, let's look at this first case. So this is f of x. This is just a regular old cubic polynomial. And I'm asking what happens, I'm always asking what happens to y. But as x approaches positive infinity, which means I'm going off to the right indefinitely, what is y doing? Okay, and in this particular case, assuming that nothing happens on this graph that I'm not seeing, but this is just a cubic, assuming that, then this y is going down indefinitely, which means y is going off to minus infinity. So what I say here, and what I'm saying in this equation right here, is that the limit as x approaches positive infinity of f of x equals minus infinity. Okay, so again, I'll say that one more time because there's a lot of infinities involved. As x is going off to positive infinity, y is going off to minus infinity. Okay, so in this second case here, I'm going to ask the other question. I'm going to ask what is happening as x approaches minus infinity. Well, I look off on the left-hand side of the graph, and I notice that this graph has a horizontal asymptote, right? And that horizontal asymptote is y equals 0. And we already know what that means. That means that y is getting really close to 0 in this direction, which is actually the answer to this question. The answer is 0. Okay, so what we're doing here is we're saying if something has a horizontal asymptote, that is actually the end behavior of the graph. That is what is happening as x approaches infinity and minus infinity. In the case of a rational function like this, they're always going to be the same from both directions, or both as on the right and on the left. And so in this case, the answer to this is a number, whereas before the answer to this problem was minus infinity. Okay, so there's a lot going on conceptually, and I think the most important thing is to go back through these slides if you are confused and see if you can understand the picture and the question that's being asked. And I think once you understand the question that's being asked in each case, you'll be able to look at that graph and answer that question. These limit problems aren't really hard once you understand what they're asking. All right, so I look forward to discussing this in class. I hope you guys have a great evening. Talk to you later.